For the following exercises, solve the equations below and express the answer using set notation. Okay, so let's get down to it. This one, we want to solve for the absolute value of 4x minus 2 equals 11. Okay, so the name of the game is always you want to get x by itself. However, x, and with this 2 and with this 4, is being trapped inside of this absolute value function, right? So I can't do anything to this side of the equation because the whole side of the equation is trapped inside of this absolute value. So first thing is, the absolute value of a number, or whatever is inside, will always produce out a positive answer. What happens if this actually equals a negative? You're still going to get a positive answer. So, if you think that you can't go any farther, the next step is break this equation into two. The absolute value is always going to give you the positive answer. However, there's a secret negative answer, and that's how we progress further. So, once you split this into two, and you say 4x minus 2 equals 11, that's what was given. And now, just know that it could have been a negative number, however, the absolute value only gives positive numbers. So this could have been 4x minus 2 equals negative 11. And once you do that, you strip away the absolute value, and you can actually solve now. So if you can't progress any further, split the equation into two, write out 1 is equal to the positive answer, 1 is equal to the negative, get rid of the absolute values, and now you're ready to solve. So we actually have two equations here. So if I just put like a nice line down the middle, we are ready to go. So on the first side, or the left side, all we just got to do is just solve for x now. So plus 2, these cancel. We got 4x equals 11, 12, 13. Divide by 4, divide by 4. Your first answer is x could have been equal to 13 over 4. Cool. Can't simplify that unless we want a mixed fraction, but nobody likes mixed fractions. We like fractions. Let's do the next one. So I still want to solve for x. So plus 2 again, this will cancel. We're left with 4x equals negative 11 plus 2 would be a negative 9. And then divide by 4, divide by 4. X would equal negative 9 over 4. I can't simplify that either. So here are my two answers. X could have been equal to 13 over 4, or x could have been equal to a negative 9 over 4. But that's not good enough for this question because we need to express the answer using set notation. What the heck is set notation? Standard is seeing these pretty nice squiggly lines. And maybe I'll put it over here. So set notation is expressing your answers in squiggly lines. And the standard of set notation is that you always go from increasing numbers. So you put the lower numbers on the left and the higher numbers on the right-hand side. So you have to identify out of your two answers, which one is the lower number. Well, in this case, this is a positive number. There's no negative. And this one clearly has a negative. So this one would be the one that goes first. So I would say negative 9 over 4. And now I just want to say that I have this answer as well. So, comma, 13 over 4. And, that was an ugly 4. And that's it. There you go. That's set notation. Squiggly lines, and then go to increasing numbers. So that's the answer for the first one, guys. Let's do the second one. Okay, now this one is a little different. It's now 2 times the absolute value of 4 minus x. Equals 7. Now, we still want to solve for x, right? It's trapped inside of the absolute value. However, can we still try to get x by itself? Well, I have this 2 hanging out outside here. which I can throw to the other side. And remember, you always do the opposite property, right? So it's being multiplied 2 times the absolute value. So if you want to get rid of the 2, you have to divide by 2 first. And I do that on both sides. And that will cancel the 2 on this side. And I have the absolute value of 4 minus x equals 7 over 2. And now we kind of have this idea. You see how now I still want to solve for x, but everything is being trapped inside here. I can't progress further. That's when, I don't know why my voice is, That's why you have to separate the 2 of them. So we're going to rewrite the one that we just stated, 7 over 2. And just like the last one, it could have been equal to a negative 7 over 2. And once you separate into the 2 equations, you get rid of the absolute value sign, and now you just solve for x. So let's do this. So I want to get x by itself. So I have minus 4 on both sides. This will cancel. You have negative x equals 7 over 2 minus 4. Now, I mean, if you want to use your calculator, go for it. I think this would be a negative 1/2. Let me just see. Yes. So this would be a negative 1 over 2. But we still want to solve for x, right? We don't want negative x. So you just do the opposite. If you want x, it won't be negative 1/2. It would be just 1/2. So that's your first answer. X equals 1/2. Now we just got to do it for the other side. So let's see. Minus 4 on both sides. Negative x equals, and this cancels. Negative x equals negative 1/2 minus 4. So I think that's negative 15 over 2. Let's just see. Yes, negative 15 over 2. But just like before, we do not want negative x, we want just x. So you just flip the sign. So it would be x equals not negative 15 over 2, but 15 over 2. There you go. Okay, here are your 2 numbers. Now we just have to put it into set notation. The hard part is which one's going to be on the left and which one's going to be on the right. The lower number goes on the left and the higher number goes on the right. If you want to divide these and actually get like the decimal number, so like what 1/2 is or what 15 over 2 is, that's fine. But I want you guys to be more comfortable with fractions. They're not that hard. They have the same denominator, which means that you can tell which one is larger by just looking at the numerator, the top number. Since a 15 is a larger number than a 1, this one has to be the greater number. The whole thing is that you need the same denominators to do that. So this one is greater, this one is lower, so the 1/2 goes on the left, comma, 15 over 2 on the right. And that's it. Woohoo! Last one. Okay, 3 times the absolute value of 5 minus x equals 5. I try to get x by itself. And this time I can progress a little further because I have a 3 times the absolute value. So I'll first get rid of that 3 by dividing by 3, right? So I have the absolute value of 5 minus x equals 5 over 3. But now the x is trapped in between the absolute value lines. I can't do anything. I can't progress any further. That's when you split it up. Look how easy this is becoming. And once you split it up, you get rid of the absolute values. Make one answer the positive, make one answer the negative. 5 minus x equals 5 over 3. And then 5 minus x equals negative 5 over 3. Let's do it. We want to solve for x. I'll work with the left one first. So minus 5, minus 5. The 5's go away. You have a negative x equals 5 minus 3 minus 15 is negative 10 over 3. Let's see. There we go, negative 10 over 3. I always like to try to do it first and see if I'm right. However, we still want x equals. So this was a negative, right? So if I don't want the negative, I get rid of the negative here. Bye-bye. And the answer would just be 10 over 3 for the first one. Now, let's do the next one. Minus 5, minus 5. That goes bye-bye. Negative x equals, now let's see, negative 5 over 3 minus 5. I believe that's negative 20 over 3. Let's see. I'm just plugging it into my calculator. Yep, negative 20 over 3. But then, same thing. I don't want negative x, I just want x. So, if I get rid of the negative here, I gotta flip the sign for the other one, so bye-bye. And that's the other answer. Now we just gotta put it into set notation. I'll put the set notation up here. Which one is the the smaller number? Which one is the larger number? Well, they're both positives, so I can't, do it that way, but they have the same denominator, right? So just look at the numerator. Which one is smaller and which one is larger? This one is larger. 20 is larger than 10, so that means that this has to be bigger than this. So this number will come first. 10 over 3, comma, 20 over 3. Oh, yeah. And that's your set notation. Look at you guys. We did it. I hope that this helped. I hope absolute values aren't as scary anymore. And let me know in the comments what you thought about this. And, if it helps you, please give this video a like and subscribe. And thank you so much. We really do love helping you guys out. And I hope that we are helping you guys out, all right? So keep up the awesome work in your math class. And I will see you all in the next video. Have a great day. Bye-bye.